We remember that gas and oil leave platforms and reach the mainland almost unchanged. For example, gas from the Lunskoye A contains ethylene glycol, produced water and condensate, and a blend of liquid hydrocarbons, while crude oil from the northern offshore platforms has associated gas. Now, this whole mix must be separated. The verb comes from the Latin word separatio. Here is the first separator. It is called a three-phaser here because it divides natural gas into three components: methane, condensate, and water with ethylene glycol. Well, simply put, gas is separated from liquid. Yet nothing is dumped or discarded. The OPF is eco-friendly and interconnected with all facilities in the chain of production, conditioning, and transportation of hydrocarbons. It even generates electricity on its own by burning natural gas produced on the platform. But that's not all. The energy from these gas turbines is enough to operate the entire facility and the offshore platform as well. From here, electricity flows back along an underground cable to Lunskoye A. This is an operations diagram of the whole OPF complex. Ethylene glycol is dewatered and directed back to the Lun A platform for reuse. Condensate extracted from natural gas is blended with oil to form a single product. Purified from water, ethylene glycol and condensate treated natural gas is fed into a separate pipeline. This is how the whole system works. But there's a catch. Any gas field has reservoir pressure, in other words, underground pressure. For example, it is 110 bar in different wells for the Lunskoye field, while it can reach 115, 117, 120, even 125 bar for other ones, for now. But as gas is produced, reservoir pressure naturally decreases, and gas should be fed to the onshore facility at a pressure of at least 86.5 bar. What do we do in this case? The answer is to build another facility, an OPFC, compression station. It will be integrated into the OPF. This is the very place where the compression station is connected to the onshore processing facility by its main pipelines. That is, currently natural gas is supplied this way, directly to the OPF. And after the commissioning of the OPF compression station, the flow will be like this, getting the necessary pressure from the compression station compressors and then returning here and then to the onshore processing facility. At the heart of the OPF compression station are powerful gas compressor units. They will compensate for the drop in Lunskoye gas pressure. Literally, as the name of the station implies, compress it. In very simple words, the purpose of the OPF and the OPF compression station can be conveyed in three words: separate, compress, and feed. That is, separate initial crude hydrocarbons from the offshore platforms into their component elements, maintain pressure, and dispatch the products, such as oil and gas with over 90% methane, further along the process chain. So the story ends where it began. Let us recall. Here are the gas pipes from the Lun A platform. There is an oil and gas pipeline from the northern offshore platforms of Sakhalin. This is what is fed to the OPF. And literally a few meters away, there's the outlet. a pipe with oil to which condensate was added here, and a big yellow gas pipe. Well, Godspeed. This route runs almost along the entire island. Approximately in the middle, the Trans-Sakhalin pipeline system passes through the booster station. Its purpose is similar to that of the OPF compression station, to maintain gas pressure up to the final destination, the Prigorodnaya production complex.